I joined the board when I retired. And I am very delighted to be able to introduce Simon Friedman, our speaker for this year's Emeritus College festivities. I've known Simon for many years. Indeed, I met him for the first time only 3 days after I moved to Kansas City to take up my new job at UMKC in 2008. Simon, and he insists that he had nothing to do with what transpired during this first meeting, but I have to say he was in the room or the backyard where it happened, so I consider him to be culpable for this. Simon, along with a bunch of other UMKC friends, were celebrating the birthday of one of their group, Bill Gutile. And my dear friend Ginny Blanton brought me over to the house, Bill's house, where the party was going to get started. The people there, including Simon, were intently involved in a DIY project, which is what Simon is denying he had anything to do with, but he was there. He was hovering, he was there. What they were doing was building some kind of chimney device for an outdoor fire pit. The gentlemen engaged in this project included 3 chemists and an engineer. That should have been my first warning. Within minutes of meeting all of them, we were engulfed in a cloud of thick, acrid smoke. This set off a massive asthma attack on my part, and Ginny, apologizing profusely the entire time, had to take me home. So I never got to celebrate Bill Gutile's birthday or see if the chimney thing actually worked in the end, which I suspect it did not. To this day, Simon, Bill, Reza Darkhshani, and the other participants in this experiment in backyard smoke inhalation referred to the party as the day we tried to kill Linda. In the intervening years, Simon has been an energetic host of a series of extraordinary annual events that have become legendary among a certain collection of UMKC folks, and Charlie Worry can attest to this. He is a master soup maker, an award-winning filmmaker, an artist, a poet, musician, and composer, and apparently now a filmmaker too. He's writing a screenplay. And he's a pretty darn good chemist besides. I asked him to explain to me in language a medieval historian could understand what exactly is a macromolecular chemist. So here goes. Simon told me that in his field of macromolecular chemistry, scientists synthesize molecules in order to understand the biological properties of certain phenomena so as to treat disease. And I got Simon's approval on my interpretation of this. Simon engages in studies that impose reactions on certain kinds of proteins to change their properties and behaviors. His best known study, which is also the best funded and is ongoing, has to do with controlling the uptake of insulin, which is injected subcutaneously by subjecting it to light. This, he tells me, is called photopharmacology. And no, it has nothing to do with a certain White House denizen who suggested that COVID-19 could be treated by shining a flashlight down one's throat or up one's nose or up something else, for all I know. The insulin is inactive until the light, which is shown through the skin at the point of injection, hits it. The goal of these experiments is to create an entirely non-invasive therapy for insulin-dependent diabetics, one that will also interact with a continuous glucose monitor that is also non-invasive. This would, as you can imagine, be revolutionary in the treatment of diabetes, which can be a tortuous process for the person who has to rely on insulin to live. Simon's creative life and his professional life both involve a lot of experimentation and a lot of assessment and reassessment of both the materials and the processes used. Therefore, I think that his title for this talk, Between Known and Unknown, Dwelling in the Discomfort of Ambiguity, is a perfect description for both his creative process and the impetus for his life's work. So without further ado, I give you Professor Simon Friedman.
Thank you very much, Linda. I agree that I don't remember any of that great smoke out when you arrived in Kansas City, but I'm glad you're here. So hello, good evening, everyone. It's a real honor to be presenting to you tonight. And in thinking about this, I realized that in this room is getting close to a person millennia worth of scholarly and teaching activities. So I'm honored that you'd select me to present to you today. So let me see if this works. So I'm going to talk today about some things I've been thinking about for years, which is this space between the unknown and the known, and that trip that we take as scholars to get to the known, and that place we find ourselves in when we are not quite there and things are ambiguous or confusing, and how we deal with that, the psychological challenge of that. And this is going to be a very tight 2.5-hour talk. So it's 30 minutes. And I've been told that my cake will be protected while I'm up here. So if I go on too long, maybe it'll just disappear. Okay. On the side, there we go. Okay, down. There we go. So I'm going to be giving several examples in this talk that are from my world of science, but it's supposed to be a somewhat universal kind of talk in that the term science can really be used interchangeably with anything where we use critical thinking to analyze a system. So this could be in literature or history or anything really. But I'm going to be giving examples from the world of science. And so, the scholar's path is we take this trip from the unknown, hopefully, to the known. And of course, philosophically speaking, we're never nothing is ever 100% known. We have varying degrees, percentages of the state of knowing. But I'm just going to call it known if we pass a certain threshold and, and realize that, yes, we can call it known, even though nothing is ever truly completely known. And in that process of going from the unknown to the known, we end up oftentimes in this place in between where we have incomplete information, limited information, and a state of confusion or ambiguity over what that information means. That's where we're the place that we're existing. And the challenge is that can be a very uncomfortable feeling, having disparate things, disparate pieces of information that are not consistent with a single model. And our challenge as scholars is to kind of try to hold those competing ideas in our mind at once as we struggle through and reach the promised land of the known. So I think there's something profoundly uncomfortable about that feeling, at least that's my experience of it. And it's something that we kind of have to fight through if we're going to resolve those ambiguities. So this makes me think of, the difference between a normal person and a hero. The normal person in the presence of danger, runs away, but the hero in the presence of that same danger runs towards it. And, that's the salient feature that really describes the hero. And I would say, in the terms of what we're talking about here, that the normal person tends to run away from ambiguity, tries to believe that they understand something. And I like to think that scholars, on the other hand, are actually drawn to that ambiguity and run towards it. Not to compare us with heroes or anything, but there is some parallel there in that we are going towards the thing that a lot of people would run away from. And why? Why do we run towards that ambiguity and that confusion? Well, A, it's our job to figure things out, but B, it's also that oftentimes it's those things that are strange and are confusing and isn't clear what they mean that are the most fruitful and will have the biggest payoff and be the most meaningful. It's sort of the universe waving a flag at us saying, look over here, there's something going on. But I would say and everyone, as I think, fears or feels uncomfortable with that. And why is that? I don't begrudge people that feeling, even though it's something we fight against as scholars. And I think it's in part because we have to believe something in order to navigate the world. We can't entertain every possible model of the universe around us. We have to sort of distill it down to one most likely thing and then navigate the world, even if it's an imperfect model. It's hard to navigate the world if you're considering all the possibilities. And so I think it's something that was forged through evolution, that we didn't constantly think about all the possibilities, and that there's something sort of limiting about that. And Shakespeare talked about that through Hamlet, the danger of indecision, and more recently, the great rock philosophers Rush also had something to say about it. If you decide not to decide, you still have made a choice. So there's a reason why people recoil and try to simplify and perhaps oversimplify just to get through life. But we don't have that luxury. And in thinking about this process, I was thinking about science, and because in a way, by resolving these or engaging with the ambiguity, we're kind of going against the grain of life. It made me think, well, is science itself a natural activity or isn't it? And I came to a conclusion that yes, it is a natural activity. And no, it isn't a natural activity. So see, there's the ambiguity already. There's multiple parts to science. There's the natural part, and that's the thing that everybody does, which is to observe the world, to ask questions, what does it mean, and to hypothesize, to come up with a model of what's going on. That's something that we all do. And this, in theory, is a video of a baby crawling towards the camera, looking very curious. You're just gonna have to, well, you can kind of see he looks kind of curious, but he looks even more curious in motion. But the bottom line is, this is something inherent in human beings, I believe, this curiosity and asking questions. But I do believe there is an unnatural part as well, and that is the rigorous testing of hypotheses. And I think that's a relatively late development in human history. People were pondering, millennia ago, but that really formal, rigorous testing of hypotheses is and this is the danger of giving a talk in a group like this, is there's probably some historian who's deeply studied that and can correct me on that. But you can maybe after the talk let me know if I got that right. And this idea of challenging your ideas, because in a lot of places, the idea that you would consider that you're wrong and actually rigorously try to see if you're wrong is just anathema. So this is the unnatural part, I think, of science or scholarship. But really, we need both of them to succeed, that natural part and the unnatural part. And in that process of trying to figure things out, intuition is one of these powerful tools that's used. It's that part of your brain that's always working on problems, even if you can't consciously explain what it is that you're working on. And I think it's a great source of inspiration and ideas and hypotheses, but it has to be challenged. And people's intuition and gut feelings, as they call them, are wrong all the time. They have to be challenged and analyzed if you really want to know what the truth is. And this came to mind in this book, Blink by Malcolm Gladwell. It's The Power of Thinking Without Thinking, which makes the case that sometimes you can have very powerful insights because your brain is working on problems. And I don't disagree with that, but I don't think it's the entire story. Snap conclusions can easily be wrong. And we know people who really strongly believe things that are just completely wrong. And I think there's a certain survival bias because the intuition can sometimes, people have these ideas that then get reinforced if they survive. So I can give an example. I was once on a flight, and there was obviously a nervous flyer who was behind me, and he was sort of making unhappy sounds as they were getting ready to leave the gate. And every time there was a noise, he would sort of sit up in his seat and go, "Oh, that doesn't sound good." And finally they were setting the flaps, and that made a really loud noise. It's whirring away, and he just bolted out of his seat, and his wife ran after him. He grabbed his carry-on and ran off the plane. And a few minutes later, the pilot got back on the loudspeaker and said, "We're going to have to remove all the bags because somebody has left the plane." And everyone was muttering oaths to this guy. And I thought, man, wouldn't it be just divine justice if the plane he got on actually crashed as opposed to the plane we were already on? And then I thought, the second thought was, well, we would never hear that story because he'd be dead at that point. So if your intuition leads you in the wrong direction, you rarely hear that story. You only hear the stories where, oh, it saved the life. So in that process, I think there's this people's belief in their inner thoughts without analysis kind of ranges the avidity with which they hold on to that, so from complete caution to complete hubris. And I think there's some really interesting examples of this from the history of science. First one that comes to mind is Newton, who was a giant. He invented the calculus and then used it to explain the motion of the planets and gravity. And so, a real triumph. And then he spent 30 years pursuing alchemy, trying to turn lead into gold. And you can say, well, that's, kind of an unproductive use of that intellect. And I'm going to put a footnote on that and saying it's a little unfair because Newton really was living in a world that didn't have the intellectual framework to understand chemistry yet. So it was hard for him to pour his intellect into that region. But the bottom line is he pursued it for 30 years. And I think that's based in a hubris and based in that massive success he had already had. So, another example of this is from Linus Pauling, who of course was another great. He won 2 Nobel Prizes, one in peace, one in chemistry. And he figured out how to use quantum mechanics to explain chemistry, as well as protein structure and other things. And then he spent 20 or 30 years kind of obsessed with vitamin C, and you could argue that wasn't a great use of his time either. And I think with both of these examples, what happens is people have they get so confident in their ability, which is not unwarranted really, but sort of takes the limits off of their ability to rein themselves in when it comes to being self-critical. And this, as an example of that hubris, is a wonderful sort of moment from chemistry. This is from a journal called Accounts of Chemical Research, and they essentially did a festschrift for Linus Pauling, celebrating his life, and they dedicated an entire issue called Holy Grails of Chemistry it was dedicated to Linus Pauling. And they gathered together the luminaries of different regions, different parts of chemistry, and everyone wrote an article, and they dedicated to Linus Pauling and asked him, could you write a foreword for this and a comment for our issue? And so he was very happy to agree to do that. And he wrote the following letter, which includes, "Dear Fred, I'm pleased you should write to me about the series of articles, Holy Grails. I did not have any interest in any of the Holy Grails mentioned in your letter. I have been interested in several efforts to find the Holy Grail, that is, to find the answer to some questions I had formulated." So if that's not the definition of hubris, I don't know what is. So I don't know what the answer is really, because that it can be a powerful force driving people, but it can also drive them off the rails into a drainage ditch. So I think intuition alone isn't enough. And my belief is that the best strategy is combining that with critical analysis. As Thoreau, I think, said, build your castles in the air. That's where they belong. Now build foundations under them. Although it might be apocryphal that he said that. Somebody else in the audience might be able to correct that. So in solving these problems and getting from that state of being unknown to known, can be a very difficult path. And we're often faced with conflicting data. And that's what leads to this whole idea of the ambiguity or the confusion that's between those two states, where we start and where we hopefully finish. And oftentimes we can be confronted with some interesting pattern that's just not understandable. And this is where the idea of running towards that as opposed to away from that, I think, is important. And what I'd like to do is give you a couple examples from the history of science, one where that weird pattern or confusion was run away from, and one where it was run towards, and how it resulted in really different kind of results. So the first example is the case of Chargaff's rules. And Chargaff was a biochemist from the middle of last century, in the 50s. And he was, like a lot of people, were trying to figure out what DNA was, how it encoded genetic information. And so he was a biochemist, and he took DNA from different sources and analyzed the 4 bases that were present. And there are 4 bases, A, T, G, and C. They knew that. And he found this weird pattern. He found that the amount of A always equaled the amount of T, and the amount of G always equaled the amount of C, independent of the species that was being looked at, independent of the absolute amount of anything. The G and the C were always equal, and the A and the T were always equal. And this is for the chemists in the audience. That's what the G and the C are, and the T and the A. And so the question was, why was that? And it all makes sense in retrospect, like everything else. It's all clear looking backwards. It's that the G and the C actually had a very special interaction that allowed them to recognize each other, as did the T and the A. And that's what we now know as the base pairs. Those are the key interactions that store genetic information. But all he knew is that G equaled C and T equaled A. And that pairing of bases is what drives the forming of the duplex of DNA, which they didn't know at that time. So it wasn't clear at that time. And this is taken from one of his papers from 1951, which is just a few years before the proposed double helix. And this is from the composition of DNA from salmon sperm. And here is table 4, the smoking gun, where the ratio of A to T is 1.02 and G to C is 1.02. This was not the first paper like this. This was one of many. And in fact, in the discussion of that is kind of a depressing statement. As the number of examples of such regularity increases, the question will become pertinent whether it is merely accidental or whether it is expression of certain structural principles that are shared by many desoxypentose nucleic acids, despite far-reaching differences in their individual composition and the absence of recognizable periodicity in their nucleotide sequence. And then the killer sentence is at the end. It is believed that the time has not yet come to attempt an answer. So that is a sad sentence, because Chargaff, my understanding, was bitterly disappointed when Watson and Crick, using Franklin's data, put 2 and 2 together and drank Chargaff's milkshake using there will be blood terminology, and figured out that it wasn't by chance that those things were in that ratio. It's because they were forming these base pairs that were key for recognition and for copying DNA. And as is said here, it has been found experimentally that the ratio of the amounts of adenine to thymine and G to C are always very close to unity. And of course, they cited Chargaff, but they won the Nobel Prize. So the lesson to me is in that to not recoil from ambiguity or confusion, but to embrace it and worry, as in the verb, worry the odd pattern. So, and it is always time to attempt an answer, I would argue. So my last example is a less depressing example, and that is the discovery of C60 fullerene, which is this cluster of 60 carbons that's shaped like a soccer ball. And this is actually work done by our Kansas City's native son, Richard Smalley, who went to Southwest High School right here on Warnell. And he, with Croto and Curl and a couple of graduate students, discovered C60 fullerene. But basically, they were looking for how carbon formed clusters in interstellar space. And Smalley had built this machine which fired lasers at materials, chunks of carbon, and was able to analyze by a mass spectrometer, weigh the clusters of carbon coming off and figure out what was being formed in the process. And what they found was a curious result. They found lots of clusters of carbon, and they had this initial pattern of every 2 carbons. So they didn't have odd numbers of carbons, always even numbers of carbons. And that kind of makes sense because you can imagine that carbons really want to complete as much of their valencies as possible. But then the extra curious result is the fact that at C60, there was, it was a little bit higher than the other species, higher than 58, higher than 62. And this is the kind of result that'd be easy to say, oh, you know, who knows, maybe the detector is a little sensitive or something was weird about the sample. But they looked at it a bit more closely and tweaked the conditions a bit and were able to really form a lot of this special species, C60, which really stood up against or stood out from the background. And they were really confused for quite a while. If you read the history of it, it's quite interesting because they finally figured out that that made sense if those 60 carbon atoms fit into the shape of a truncated icosahedron or a soccer ball, the exact shape, the exact arrangement of pentagons and hexagons that people probably hundreds of years ago had figured out that made a good way of sewing patches of leather together to make a spherical soccer ball. It's also an excellent way of carbon satisfying all of its valencies and forming a very stable structure. So they didn't ignore that pattern. And what was the consequence of not ignoring the confusing or ambiguous pattern? Well, glory, they got a round trip ticket to Stockholm. And so I think that that is kind of inspiring. But in the process of, and this is my last point really, in the process of researching that particular story a few days ago, I looked at what Smalley had written in his biography for his Nobel Prize. And there was an extra thing an extra piece of, an extra unknown that he kind of revealed that I think might be unresolvable, but is inherent in what scholars do beyond the research, which is the teaching. And he wrote this passage. My interest in science had many roots. Some came from my mother as she finished her BA degree studies in college while I was in my early teens. She fell in love with science, particularly as a result of classes on the foundation of physical science taught by a magnificent mathematics professor at the University of Kansas City, aka UMKC, Dr. Norman Royal Jr., and I assume that's what Royal Hall is named after. I was infected by this professor secondhand through hundreds of hours of conversations at my mother's knees. It was from my mother that I first learned of Archimedes, Leonardo da Vinci, Galileo, Kepler, Newton, and Darwin. So I think this is the final thing, an unresolvable unknown in being a scholar is the impact of one's teaching, because I'm sure Smalley's mother had no idea that these conversations would end up with him winning the Nobel Prize. And if that's the case, there's absolutely no way that Royal had any idea that 2 generations down, the things that inspired his students would then inspire people after. And I think that's an important point to remember in the process of what we do. And that's the final lesson I take from that story. And with that, I'm done and I get to eat my cake. So, oh yeah, I'm happy to answer. Oh yeah, please.
Go back to that. Sorry, you have
Your
wait.
cake will have to wait.
You have your cake until you answer this question. So have you had any personal experiences with this?
Yes.
You could share?
Yeah, I mean, I have unresolved patterns that I still keep in my mind, projects that have no longer funded, that have long since been shut down, that I'm still pondering. A weird, consistent spot on a gel from our telomerase project that I suspect was a particularly stable piece of RNA that always formed a structure, but I don't know for sure. So, I mean, and I used to have a picture of that on my cork board, and I would, you know, every day I'd stare at it, and, you know, so I try to live my values that I'm, you know, talking about in this talk, but it can be frustrating, but I don't want to give up on that. And so there is a little corner of the mind that still has that, that gel. And maybe some other paper at some point will click and go, oh, that's the explanation. But the only way we have of possibly resolving those ambiguities or confusions is to not let them go and to keep them, you know, on your radar scope. Maybe it's not in the middle of it, maybe it's on the edge, but to hold on to it. So. Yeah.
Can you talk a moment about your journey from science into the creative world?
Yeah,
All the stuff that you're doing.
yeah, I don't know if well, I mean, I've always made the argument that science, and people don't necessarily know this who are outside of academia, that science itself is a highly creative activity. And people think it's a bunch of, you know, geeks with pocket protectors. And yes, we have pocket protectors and we are geeks, but it's more than that. So I think of science as being a highly creative endeavor by itself. So my creative life, I've always had that, and it's not, I think they're kind of integrated in a way. They're both, I hate talking about, I really sound like a pompous jerk talking about myself this way, but they're, that they're both reflections of a creative urge, I would say. And so and it's a lot easier being a scientist who writes on the side than a writer who does science on the side. That's definitely, I think that's true. So.
Person that we encountered who had the largest pocket protection pencils is actually the architect who designed our home and did illustrations. I remember sitting with him and thinking, gee, that guy's got 10 colors in his plastic protection.
Architects are interesting. Yeah. I appreciate that. Well, that's an interesting sort of confluence of the technical and the artistic. I mean, it's inherent in that. It definitely is an intersection of those two things. I like pens too. I have a favorite pen. I went to the high school I went to I had to take 2 years of technical drawing as part of the curriculum, and so I'm familiar with that world. Yes.
So one of the things that strikes me about your talk and about creative process as it develops is that there is a real sort of contrast between hubris, which is this technically hubris needs a state of knowing, right? A conviction that you know everything and that you don't need to learn anything else. And I think that that creative process really is about unknowing or learning what you don't know rather than being convinced about what you do know. And so I suppose my question is, do you feel that that real creativity, that real searching and exploration, the stuff that happens that creates discoveries that lead to Nobel Prizes, for example, is coming out of that state of unknowing? Or is does it require a certain level of hubris?
Yeah, I think it's interesting. I think there's a tension between the and there's this idea that it's first year young graduate students that make big advances because they don't know any better. They don't know that this is not going to work. And what I find that as I move along in my career, in some ways my thinking is more efficient. I've seen more, I can see more connections, and that gives a certain hubris. But I also recognize the danger of that, because in fact, I was going to incorporate that. There was a recent psychological study where they talked about cognitive traps and how children do not fall into cognitive traps because of the inefficiency of their thinking. They're kind of considering everything. And because of that, they don't get trapped. Whereas the hubris, and I think maybe this links up with Pauling and Newton, the hubris that comes from that efficiency of thought, that comes from the experience, if you don't add in the extra spice of the childlike open quality to it, that's what leads to. So it's like the yin and yang kind of thing, that I think you need both. You need that childlike quality, and of course, all that experience is also very useful as well. So it's everything in life seems to be the thing that's in the middle usually is the best thing. The extremes are not they're fraught maybe.
Did you already explain this, or did you explain
I did. I was hoping someone could explain it to me. No. These are, and it's so I was doing those for years as kind of a compulsion. I drew them in largely faculty meetings. I was very carefully listening to the proceedings as well, of course. And then at some point I thought, well, I'm doing it on these these sheets of paper, and my colleagues seem kind of, at least bemused, if nothing else. So I thought, well, maybe I can make one that's 8 foot tall and 4 foot wide, and then, but it is kind of a compulsion in a way, so I started making them large, and it's something it sort of defies articulation maybe, although to me they feel kind of biological, and I feel like they kind of evolve. I draw them freehand. I don't plan anything out. It's I just kind of go where I want to go, and then other parts of it start communicating with other parts, and I've got sort of aesthetic rules that I follow, and I think that's about all I can say. The normal, I have a website you can, which is artofmanylines.com. And as Linda said, it's frustrating because none of them are for sale, because I don't want to let go of them. But anyway, but the bottom line is you can see what they look like at a larger scale. They look a bit different than this. This is the kind that would fit onto a mug. And, it's not, I'm not even convinced it's really art, but yeah.
What did you say the website was?
Artofmanylines.com.
It's in the Beacon.
It's in the Beacon. Yeah. So.
A little article about Save the Date.
Yeah. Oh, Charlie.
One of the things I was struck by during your talk was the word inspiration. Where would that fit into your view of knowing and not knowing, and many examples throughout science history of the eureka moment always seem to occur?
Yeah, I mean, and so that would suggest that sometimes these intuitive moments can be absolutely profound, and a solution just pops out fully formed and perfect. And yeah, so I can't, I better be careful about dissing intuition too much, because absolutely. And I mean, I've had times when I've woken from a dream where I had an idea that actually was, pretty real. It wasn't just odd. Yeah, I agree. There definitely are examples where intuition is profoundly just points the exact direction. And so, yeah, I think I'm a kind of a sober-ish individual, although I can be reckless in my own way. So I'm always looking to sort of balance these forces, which that gut feeling versus the analysis that overlays that to ensure that you're not going off in the wrong direction. But given that, I agree, there absolutely are examples of Archimedes and all that, the eureka, literally eureka moments that are real. I mean, the base pairing that was Watson, he had these physical models and he was just shuffling them around on the table, and he suddenly realized they fit perfectly. And that was, he something in his mind clicked in the same way that the physically clicked together. So.
You talk about the base pairing, and I'm sure it didn't happen this way, but the first time that I read the Double Helix, which is the book that Watson wrote, science has told us that the key is that the helical backbones are outside double helix, and the AT base pairs and the GC are inside. And so they basically have to, and an AT base pair has to have pretty much the same shape as a GC. And I remember when I was reading his book the first time, I was very struck by he was talking about how he came up with this. And it seemed that they wanted to get models that they could put the A's and T's together. And it was taking some time. And then the guy down in the shop finally came up and he had these tin cutout. And very shortly after that, they decided that the AT and GC was a key. And I remember thinking, well, it would be really kind of cool if the way science goes forward is if the guy in the shop came up and he said, well, I didn't have very much metal, so I had to figure out a way to make all four faces. And I figured out that if I made this one shape, I could two separate ways.
Right.
Now, I'm sure it didn't happen that way, but
who knows?
I bring it up and I get this. I mean, I suspect that you have to be prepared to get some kind of an insight from all sorts of sources.
Absolutely.
And, it can be really pretty strange.
Absolutely. And what I find interesting about the thing with the base pairs with the physical models is that allows a certain amount of play. He was playing, and that kind of, in a way, in some people's minds, sort of lowers it as an insight. Oh, he was just playing around with Tinker Toys. But in fact, with C60, it was the exact same thing, smally cut out pentagons and hexagons, and realized that when you put hexagons around a pentagon, it started to curve. and he was reinventing Euclidean geometry that was known thousands of years ago. But at the same time, it was a physical model and that playing. And boy, oh boy, you know, I do feel that it's important just in education to sort of maintain that, you know, that feeling.
I admit I'm reminded of a Far Side cartoon. That's one of my favorites of Albert Einstein sort of standing in front of his blackboard with you know, with all of these notations, and he's like standing there and kind of pounding on it, and his house cleaner is standing behind him with her Hoover and saying, well, this is all squared away. It's just squared away.
Right, because he's written E equals MC cubed, and he's got a cross through it, and E equals MC, and he puts, and then she's like, oh, it's all square, and it's like, so yes, so inspiration can come from, well, as Pasteur said, you know, chance favors the prepared mind, and
Exactly.
in fact, our beloved Eckhart Helmut, because I was involved with fullerenes, and he came to me once and he said, you know, there was a time we were doing a study and we got a mass spec which had C60, and it was some other completely different kind of experiment, and we just kind of ignored it, but it was something that it had cropped up in other people's hands, and it was confusing and weird, but so the key is that maybe that's where the intuition comes in, that this is something worth looking at, you know, and trying to figure out.
The true intuition really does come from a prepared mind. I mean, you can't be inspired if you don't already have an understanding and a knowledge base that can prepare you to allow yourself to be inspired.
I agree. I think, yeah, the way I think of it is just the unconscious, all these things just tumbling around in the unconscious, all this sort of offloaded processes, like, for, you know, and the conscious mind couldn't do it, but the unconscious is trying things out as you sleep, as you do anything else, and then it pops out, and it's kind of amazing.
Thank you.
Okay, thank you very much.